Hello friends, this is the third lecture of Unit 2 DC mode. That is, we will understand about the torque equation of the DC. Come to the before going to this detailed understanding about the torque. First, we will understand about the force. If we will perfectly understand the force, then we will understand the force. Let's first we will start from the basic. That already we discussed across this working, but the thing is again I am discussing here. You see here. Suppose there is a north and there is a south, right? Now what will happen? First we understand the direction of force where it will act. Suppose there is an armature here in between this. That is a cross marks. Cross means inward current. Suppose this is a inward current. Okay. If it is an inward current, now, first you just see where the North Pole to, we know the magnetic lines will come from North Pole to South Pole. This is the magnetic lines will come North Pole to South Pole, right? Now, if this is the North Pole to South Pole, the magnetic lines will come. First point you see the current is inward direction. Okay, this is the two concept you remember. First, you identify the force. You see, if your current is inward, then come to the one rule that is your right hand thumb. In right hand thumb rule, if you will discuss, then you see, suppose this is your right hand, the thumb. This is the thumb, right? If this is your right hand and this is the thumb, then what will happen? Just put your hand like this. Okay. Now you see, you put the current direction is inward means your finger thumb will be inward. Then if you are putting like this, then you see your call finger is a clockwise direction such for the diagram it is showing. Because if you make the thumb is inward, then what will happen? Your call fingers are in the clockwise direction. On the basis of this, what will happen? Just see, I'm marking out. These are the call finger directions, and it is a clockwise directions. This is a clockwise directions, right? Now we have our main aim is to find out the force direction. You see, in this magnetic lines from the poles are coming from downwards, and here the armature, the flux is your clockwise. You just put right here clockwise, right? These two conditions. Now you just divide this armature into two for the understanding I am taking. Now you see, if I will divide this armature into two parts, something and different. You see, I am making the armature into two parts. There is a left hand side and there is a right hand side. Now clearly understand. You see, in the left hand side, this is your left hand side, this is your right hand side. You see the left hand side only. What will happen? Your magnetic lines will come downward. And if you will closely observe, this flux will be upward. If you the flux, this is the magnetic line IF, and the flux is upward. You see, red color. Okay, we can put a phi A. If we will find out the resultant, then what will happen? This both will cancel. IF, because both are in opposite. Okay, this is from your left hand side. Okay, and if you come to the right hand, you the magnetic lines will be downward, but the flux is also, if you see, the flux is also downward. That means if you say the magnetic lines phi f and phi a is same direction, It is in left hand side, it is phi f minus phi a equal to 0. But what will happen in case of the right hand, it will added up, right? That is your phi f plus phi. The concept you understand this two. That is not equal to 0. Now you see, if the left hand side is cancelled, this one, then what will happen? The cancellation of flux will occur here. We can write here that cancellation of flux, but here you can see it is the added of flux. Okay. Now you see, due to the addition, what will happen? If I will redraw the circuit, there is a north pole, there is a south pole, and the armature is in center. The current direction is like that. What will happen? The magnetic lines is only produced at the right hand side, and the direction is downward. But in this side, what will happen? There is completely blank space. Means because the cancellation of the flux occurred. Due to this, what will happen? There is much more wider space where the armature can move. And if the accumulation of flux is more here, or greater, then what will happen? This armature will move in this direction. It is a force, right? It is we are discussing about a single conductor. Similarly, if the current direction is outward, if there is a north pole and there is a south pole, and the current direction is outward dot, then what will happen? The force is your right. That same concept we will explain when we are explaining about the complete armature. Now take an example of a complete armature, then you will understand. Now you see, if I will draw this is your north pole again, and this is your south pole, okay? And now one point you've seen, we know that north pole to south pole, the magnetic lines will come. I just draw the lines. Okay. Now put the armature inside this, and I suppose this is the armature. Okay. And in this armature, what will happen? The armature slots are there. Suppose the armature slots one is there here, and definitely the opposite side another. But current one side, the current will go enter and current will come outside. This is your current in, and suppose you can say current is out. Otherwise, you can make it in. Now you see, if I will draw the diagram here, see, this is the armature because the color combinations are something different. Now see, okay, there's to understand. Suppose this is a dot. This is your cross. Now, from the previous slide, what do you understand? That if there is a dot, okay, and the north pole of above and south pole is down, then what will happen due to this? The the force will exert. This is the armature. Now, the force will exert here. The right hand. You put one. Okay, I'm talking about one conductor, and this is your force at the left hand side, right? And after some time, when the conductor position will change because the armature will energize and armature will rotate, you see this armature slot will come to this point, right? And this conductor slot will go to this point, right? Then the force will be changed to this side, and what will happen? The force will change to this point, right? Then after certain time, what will happen? They will again each other oppose. This is another one. This is here, right? Now you see the force acting here, F5, and the force acting here, F6. Both are opposite to each other, right? That means in this point, what will happen? This F5 is right direction and F6 is a left direction. And both are opposing means what will happen? The force acting on this resultant force is zero. That's why there is maybe a condition that at some time it can stop if there is a one conductor. But we know that armature contains many conductors, and that's why we are denoting the conductor is Z. Z equal to conductor. And when one conductor is like this situation, the other conductors will take care, and by which you see it will get a rotational force. You see, this force is like this, it is coming, and here also it is going like this. The total force, if you see, it will look like a circle. Or we can say that is a rotational force. Okay? We are getting now rotational force. And this rotational force is nothing but because force we know that there is one force that is if there is a surface, what will happen? There is a body, it is attached to the surface. If you will apply the more force, then the body will displace the position from this A position to B. That is your linear force. When I am talking about the rotational force, that the force is like a circular manner, okay, due to the armature construction. And as I am getting the rotational force, okay, this is called as a nothing but a torque. Okay, but when you see the torque, what are the factors you can see? One is your force, another one is your radius of the armature. Okay, that's why the torque formula is every time you remember that is force acting on the armature into the radius of the armature. That is, you can say torque, and it is the force acting on armature. Now come to the point, the torque formula we derive torque equal to force into radius. That you keep in mind. It is help to find out the equation. Okay, but we got the force. Now suppose come to the point again we discussed that is your Lorentz force. What is that? That is your Lorentz force. That we will understand from the magnetic field and a current carrying conductor, or you can say that no, current carrying conductor. Suppose you see there is a magnetic field. The magnetic field direction is from left side to right. Suppose that means north pole to south pole. Then we can say that is your magnetic flux density. Then in the from left to right. Then B is nothing but that is 5 by A. That is your flux per unit area. And what is B? Where B is your flux density. Now suppose there is a current carrying conductors. Now suppose there is a current carrying conductor, and in which what will happen? The current is flowing and the conductor length is L. As in physics, we already understand that what is the Lorentz force. And force, what will happen if a current carrying conductor or current is flowing across this conductor and it is passed through a magnetic field, then there will be a force will exert on the uh, conductor by which this conductor will move up or down. That's why what is the formula will come F that is equal to current across this conductor into that is magnetic field into or cross product into the length of the conductor. Then the complete equation we know that in the cross product means that is your VL sine theta. Sine theta means theta is the angle between the current carrying conductor and the magnetic field density. Okay. Now come to the point. If we are calculating this, then when you are getting the maximum force, there is if your theta equal to 0, then sine 0 is what? Sine 0 is 0. That's why your force is also 0. Okay, that force is equal to 0. If theta equal to 90 degree, then sine 90 equal to 1, then your force is nothing but equal to your IV, that is maximum force will H. And if you see the practical condition also, if your magnetic flow from left to right it is going, and you are putting a current carrying conductor in a perpendicular manner, and definitely when it will pass, it will intersect all the it will cut all the conductor points. That's why you are getting the maximum force. You can put here F maximum. Okay, this is nothing but your force we derived. And what will happen, we are considering the radius of the armature, that you know, don't forget that it is R is your radius of armature, right? Now we'll understand a concept that total force, that is total torque equal to force into radius Newton per meter the unit, right? Then what will happen? We will consider what is the total uh, armature torque, because it is a torque across a single conductor. Next slide. Now first point you see the in the first we will see the formula of the torque. Torque is nothing but torque, already we discussed, torque equal to F cross R is the radius of the armature and force acting on the armature. Okay, as it is a rotational force, that's why it is known as a torque. Now you see F we derived, that is equal to VIL into R. Okay. Now the point is, suppose that we know that this current is not one. Okay, because this current I denoted as a total current. I equal to the total current flowing across the conductor. And how many conductors are present in the armature? That is your Z. Z equal to number of conductors. And how the conductors are connected across the motor or generator? Then you know that we already told that it is connected in parallel. That's why A equal to number of parallel path, right? Then suppose it is the total current, and we are considering for each conductor. Then what is the current value? You see, if suppose there are multiple conductors are there, okay, that is your suppose one, two, three, four conductors are there. If there is multiple conductors are there and it is connected in parallel, then total current, what will happen? Suppose total current is flowing here, I, then each conductor will contain how much current? Each conductor means this conductor will contain the current of I by A, number of parallel paths. If suppose there is four parallel paths, then it is the four, we can say, and this is the n number of parallel paths are there. Okay, that's why in place of I, what we can write, that is your B I by A L into R, and this is for the single conductor. Then torque for multiple conductor or Z number of conductors, that is the formula will come V I by A L R Z, that is for Z conductors. Now the point is we derive this from this. Okay, we remember this one. Now we'll go for to derive the area of this. Then area for this we have to understand the what is the this is your magnetic, sorry, this is your parallel path. Now we'll derive the area of the uh, armature. How we can find out the area, because we know that from this equation the torque is equal to flux by area. Already we have written the area a already used for the number of parallel path. That's why we are putting small a to find out the area. I by a l r j. Okay. Now here you can see torque equal to flux per unit area, and that is your I by a. Now it is your r l and j. Now you find out, because of everything already we know, but this we have to find out. Now point is there is, suppose there is a pole, and the armature will be like this. And I told that armature is having the radius. Okay. And you see what is the area we are putting here. That is, you see the what is the circumference of this, because if we will consider this the area of the circle, then the area of the circle is pi r square. But you see in pi r square means only the peripheries are connected to the poles. The circle, all the parts are not connected. Okay, this is a conductor. That's why we have to only consider the periphery. That's why this pi r square we will not consider. Only we will consider the circumference of the conductor. That is your 2 pi. Another important point, when we are calculating the area, then definitely there is a term coming, that is your length of the conductor, 2 pi r. And another point is, you see the periphery, suppose there is one pole, then the periphery only conducted to this pole. Okay. Then for this region, then we have to also consider this pole number. That is your by P. I am putting. Suppose there is two poles. Here I am putting another pole. Then the pole number will be changed to 2. Okay, but depends upon the pole number. Also the periphery is covering through the poles. Okay. Then we can see the formula will develop, that is your 2 pi r l by p. 2 pi r the circumference of the armature, l is the distance, the length of the conductor, p is the number of poles. Then if we will put here, then you see the formula will come pi by 2 pi r l by p into I by a into r l z. Now you see from this you can cancel out these things, r l and r. Then what will come? That is your uh, z pi I p by 2 pi a Newton meter, right? Then we can calculate, you can simplify this one. The torque is nothing but equal to 1 by 2 pi is 0.159. Okay? That is your p pi z I by a, what you are getting. Okay. And from this, what you can see that a torque is, from this equation, you can see The torque, if I will highlight this equation, then you see the torque is directly proportional to flux and current. One relation here it is obtained and it is helpful to understand the characteristics. Okay, but till now you just understand this one, right? Now the point is, what is the formula of the back EMF? Back EMF formula, we already know that in generator case, what is the generator EMF? That is your P phi NZ by 60A. And similarly, here also the back EMF is same. Okay. But if you compare this equation, here I am also again writing the torque equation by which you can tally torque is equal to 0.159, that is P phi ZI by, right? P phi ZA by A. Now you see what is the common term we are getting? P phi Z by A we are getting. And in this equation also we are getting the P phi Z by A. Then can I write here that P phi Z by A, that is equal to 60 into EB divided by, right? From this equation we derived this one and already we derived this one. Now that is coming as that 0.159, okay, into place of P phi Z by A means it is 60 into EB by N into I, right? Now you see if I will solve again the equation, then torque equation becomes that is 9.58. If you will multiply 0.159 into 60, that will come 9.58 into EB into I by N. You can say IA. This is all about your torque equation and Newton meter. But the point is, it is what is your, you see, torque is nothing but that you can say that 9.58, that is your output power, the output power, okay, or simplify way you can write also that P out is equal to torque into speed, okay, by 9.8 you can do the formula of the torque. And when we are discussing about these things, that a torque is required to understand the characteristics, because uh, there is a speed, there is a torque, and there is a current. When we are discussing about the characteristics of DC motor, then there is two characteristics will come. One is your electrical characteristics, another one is your mechanical characteristics. Electrical characteristics is nothing but speed versus current. And another one is your torque versus current, also electrical characteristics. Because you are supplying the current as well as the torque is produced. Torque is a rotational force. Similarly, if I am only considering the characteristics of the motor in the mechanical characteristics, that is a two part. The mechanical, one is torque, another one is your speed. This will be related. The relation of this torque and speed also we can calculate, but these formulas only you have to use. What are the formulas? There is one formula is, if you will summarize, you can, this concept that torque, one equation torque we derived, that is your 0.159 P phi Z P phi Z I by A. One equation we derived. Another equation is torque equal to that 9.58 into EB into I by N, right? There is two equations. You see, If I am seeing these equations, then what will happen that can you say here there is one relation will come, torque is directly proportional to flux into current, and if this EV and I you make it constant, then torque is inversely proportional to that speed. These two equations are very important, and after this we will in this lecture you will understand about the types of the motor, then we will go for the character. Thank you for the listening and the detailed explanations. And it is inside this, everything is there. If any doubt, you can